Good afternoon, good evening, ladies and gentlemen. Welcome to this webinar where I would like to present a small concept of integrating Industry 4.0 and IBM Power Systems, what we call as Open Power Systems. And we will be doing that using a probable use case scenario, taking into account developing economies, which are in the present scenario of the economic turnaround are trying for an industrial ramp up. Right. So before I go ahead further, I would just like to present myself a bit. I'm Archisman Sen. You can call me Sen, and I'm from India. I'm a graduate and now pursuing masters, and did a small internship in Mitsubishi Fuso in Japan, and that's where the interest of Industry 4.0 and the related aspects came into existence. So I would like to go ahead. So today in this webinar, why are we here? So the purpose is to demonstrate the capability of IBM Open POWER to make Industry 4.0 transition in the developing economic landscape. So basically that means that in the developing economies, we do not hear too much about Industry 4.0. And we would like to take advantage of this rising scenario to incorporate the technological advancements that we already have from IBM Open POWER. And what are the motivations behind this kind of approach? Let's say that most of the economies are trying to become self-reliant, for which they are trying to make a strategy where they could make the manufacturing more local than going, globally local or global, let's say. So it's more local now, and the industries are shifting bases from other countries, cheap producing countries, to countries where they can have more revenues and more profits and also more control. So multiple MNC manufacturers are aiming for developing nations. So that's the main goal behind this entire presentation. So if we say that, what do we have now? We have industries which are quite advanced with the automation, and we have engineers and diploma graduates who are ready to, skilled enough to take care of these industries. But what we do need is something a bit of a ramp up, and they are called as smart industries in the arena of Industry 4.0, which would have smart automation, and basically we would try to incorporate machine learning and artificial intelligence in lieu of self-learning and improving processes. And then we have scale up for factories. That's what we need. That's really a need of this hour. So how do you go about it? So let's say we have a 4-pin strategy in which the major 4 points, of which the first major point would be to have a global approach of IBM Open POWER, which means that the industries would be using the IBM Open POWER capabilities in all those areas which it is able or which it might be able to incorporate. So, and I mean, basically it's easier said than done. So let's say, why would they want to do it? So this is a model which would like to create a perspective where they would understand that it's more affordable, and they would have a quicker ROI based system. So that's like the second point why industry would like to take this approach, right? So now we have the third point where they would like to make the best utilization of the local resources, and that would lead to further profit incentivization, right? And let's not forget, behind all of this we have the most important aspect, which is the data. So we have to take a lot of care in identifying where we would like to retrieve the data, where we would like to use that data, and henceforth. So the importance of data is really huge. So what next? So we would like to develop a system, a one-stop system, which would have an end-to-end process. This creation of the system would have been done from all the available modules of IBM OpenPOWER. And in order to incorporate all these system, or let's say the end-to-end processes, we have to train the employees with these systems in the arena of the existing manufacturing arena, right? So basically, a small phased change, let's say, of the technology, and also a skill ramp up. And why would we like to do that? So that would be another good question that any profit-making industry would like to answer. So the two main things that would be the most highlighted would be reduction in manual processes and errors, and the chance to enhance profit margins. But more importantly, also deliver quality products, let's say an aspect of Six Sigma, right? And how do they plan to do that? Or let's say, how would be they able to do it? So that would be by changing the approach of training for the new employees. What I mean by this is it's a very tricky situation when we say that we have a full-fledged automation, and we will have more incorporation of machines and machine learning and artificial intelligence. What will happen to the existing employees, etc. So that aspect could be to an extent answered by saying that, okay, we will have a phased skill ramp up, and these would lead to less of iterations in the number of employees in the organization, and we would tend to lose lesser of the more skilled people, or people who know the existing systems well. So the phased training process would be one of the aspects which would be really, really important. And then we have the introduction of trainings and systems in the institutions. So basically the graduates or diplomas, or let's say the postgraduates, would have the learning factories, which we really tend to call these days. And these would be the centers where they would be exposed to the systems, which would be really functioning, and although in a small scale, but they will be exposed to the system in order to be able to implement the knowledge which they gain in the institutions when they come to the industry. The third approach would be like to create some open research and competition collaborations with institutions. So basically, this is something more of a open, game day or something like that, or open competition day. So this is another approach. So that leads to more of self-learning and self-skill-up processes within people who are interested into divulging in this kind of industry, right? So what does it mean to establish an E2E system with IBM OpenPOWER? So when I said an end-to-end system, I wanted to refer that we would have real-time optimization of the process. So let's say we have a system and we want to optimize each of those processes. But however, sometimes we do not have an opportunity to implement the modules that are existing from IBM OpenPOWER. So we would try to maximize the utilizations of these modules and optimize the process itself. Meanwhile, we will also have real-time feedback loops through AI and algorithmic factor-based sorting. So this is something which is again interesting. And in lieu of this, we would be able to create a customizable E2A system. For example, an FMCG industry would have a completely different requirement of an E2A system or E2A production system, which is more digitalized for the industry 4.0 than an automotive industry, or rather, let's say, logistic firm. So we would, utilizing these systems or the modules of IBM OpenPOWER, we would be able to create customizable E2A system so that we can provide services to most of the sectors. So optimized use of IBM Cloud is another factor which could actually lead to a lot of help. I mean, basically, let's say that IBM Cloud is underutilized, so we can actually utilize it to a larger, greater extent and provide more facilities out of it, just like Amazon Web Services does these days. So this end-to-end system basically is the creation of the digital twin in the long run. So that's what is the final goal of this entire project. So after explaining what the end-to-end system would look like, I would like to highlight something about the use case scenario. I mean, using a use case scenario so that it's a bit more clear of how to go about it. So let's say that we would like to do some product quality tracking, and let's say a product A is being manufactured by some XYZ company, and it has sub-suppliers and suppliers and OEMs and dealers and distribution centers and sellers and then consumers, and then we have the recycling process. So I mean, I have in these hexagonal boxes, I have all the life cycle management system highlighted. So if I'm looking at any one aspect of it, and I say that, okay, let's say that we have a problem in any one of these areas. Let's say the sub-supplier has a problem in one of the components, and or the supplier has a problem in one of the components. So what next? How do we do it? So basically, in the recent times, let's say out of the, as you can see here, out of the 350, let's say, random small components, we have a complaint from the field, and the failures in 4 years leads to a greater warranty claim. So a lot of research is being done in the quality analysis field. We do some Pareto, RCA, root cause analysis, fishbone analysis, and then we have the FMEA, and henceforth. So a lot of time is taken, a lot of personnel is devoted, and a lot of money is being used for that. At the end of the day, of course, the components are identified and the suppliers, or let's say the point of origin of the failure is identified and it's resolved. Great. So what do we have in the new system is something called component voice tracking, so that if a component fails at some point and if it is iterative, then we would like to track without utilization of personnel in a scale which is as huge as today. So the main target is to do the tracking of the quality failure without the utilization of personnel. So we can use a lot of technology for that. In fact, IBM Open POWER has a lot of technology within its arena. So we can have actually codings and numbers and sensors in the production system where it would be tracked remotely, and then control charts are redefined. And the research is done for new adjustments, and the solutions are narrowed down with lesser utilization of the budget or the monetary allocation. So this is one of the aspects where I would like to say that the quality tracking would become much more faster, much more easier. Although we would have applied a lot of technology and sensors, etc. But what I would like to highlight here is we have the capabilities within the IBM Open POWER Systems. So we can actually utilize a lot of the IoT and the edge computing from IBM Open POWER, which would actually lead to faster resolution of a problem of this sort. So this is just one of the use case scenario, and these kind of scenarios are plenty, numerous in a manufacturing scenario, and these all could be put under one umbrella to have a wholesome E2A system, so that could be tracked, monitored, and fully functional to provide more better results. So the implementation plan is pretty simple. It's kind of a cycling nature. So we would have development teams which would dedicatedly develop the E2E system based on a generic plan, basically. And these independent modules which we have from IBM Open Power would be looked further for how they could be integrated, and cross functionality of each of these modules could be achieved, and they could be made as a unified system. This is basically one. And then looking at the company's perspective, we would have more we would like to have more companies onboarding because of the unique ROI plan that we provide them with, and unique business models that we provide them with. So after all this is done, we would provide a demo architecture, demo system, and this would lead to probable use case of the requirement based for the company, or let's say very specific to the company itself. And then the universities would have the training modules. Once the system is developed, basically this integrated system of IBM is developed, the universities would have some hands-on training for the personnel for getting trained, the students to get to get trained and come to the arena much more ready to work with the systems already available. So what could be the next steps henceforth? We could have more companies getting the service of the E2E system. The stage for the digital twin is set up. Next is we would unlock the full potential of the IBM Open Power, and that would lead to revamp of the manufacturing arena. And then we would have a one-stop destination of manufacturing like scenario, which we often like to say that, okay, Microsoft is for computers. So we could say that, okay, IBM Open Power integrated system is the one-stop for manufacturing arena, something like that. That's all for my presentation. Thank you very much for joining today. And I would like to open the floor for any questions that you would like to ask me.